This is our practice homework video for class 9/9/16 Friday, and we're using our practice packet, not our math book, and we're doing lesson 1, problems number 1 and 2. Make sure that you're using ink to correct or finish any problems that you didn't already do by yourself. The first question is telling me that x and y are in a proportional relationship and that I have to use that fact to complete this table. So the first thing I am doing is I am looking for a place where I already have both the x and the y, which I have right here, the x and the y. Now, being proportional means that if you divide the y by the x, you will always get the same number. So in this case, if I divide 15 by 5, I'm going to get 3. So that means that I have to divide 21 by some number to get 3, because if it's proportional and you divide y by x, you're always going to get the same number. In this case, I did 15, that was my y, divided by 5, that was my x, and I got 3. So 21 divided by what equals 3? Well, the answer to that is 7. Okay, now look at how you can reverse it. 7 times 3 is 21. 5 times 3 is 15. Okay, now let's do this one. Since this time I don't have the y and I can't divide, I have to work this way. So instead of doing dividing, I'm going to do 3 times 3, and 3 times 3 is 9. Now I'm just going to check my work. 9 divided by 3, y divided by x is equal to 3. And so I know I have the correct answer. And on my last one, I have to do 4 divided by some number to get 3. Well, that's kind of a weird problem where you're doing 4 divided by some number to get 3. So to help me understand a little bit what I could divide 4 by in order to get 3, I'm going to go back and look at this first thing that I set up. Remember, I said that if a relationship is proportional, then you can take the y and you can divide by the x, and you're always going to get the same number in this table. 21 divided by 7 is 3. 15 divided by 5 is 3. 9 divided by 3 is 3. Well, I can also set up proportions if it's a proportional relationship. So in my first problem that I was working with, I did 15 over 5. And 15 over 5 is the same thing as 3 over 1. Now 3, that 3 is this same 3 right here. Okay, I put it over 1 because I'm setting up a proportion. 15 over 5, this fraction, is equal to this fraction, 3 over 1. How do I know that? Because 15 divided by 5 is 3, and 3 divided by 1 is 3. Well, if I can do that for that problem, set up a proportion, then I can do that for this problem. So I'm going to write that 4 over x is equal to 3 over 1. And now I can solve this proportion. I think you learned how to do this last year by cross-multiplying. 4 times 1 is 4, and 3 times x is 3x. So I write the problem 3x equal 4. And then you should know how to solve a simple equation like this. I want to get the x by itself, so I have to undo multiplying by 3. And to undo multiplying by 3, I use the opposite operation of division. And I divide by 3 here, and I divide by 3 here, and that gives me x equals 4/3, which is the same as 1 1/3. And so the answer to that was 1 1/3. I'm done with my table now. Now, I'm going to insert a new screen so I can do the second part of that same question, because the second part said, what is the constant of proportionality for this relationship? Well, the constant of proportionality is the answer you get when you do y divided by x. And we did 15 divided by 5. And what answer did we get? We got 3. So that is the constant of proportionality. It's the number you get every time in this table when you divide a y by its x. Every single time when you divide this y by this x, you're going to get this 3, constant of proportionality. Okay, and one more problem, number 2. Oops. This one says that Lynn pays $3 per soda at the baseball games, and if X represents the number of sodas and Y is the total cost of her sodas, are X and Y related proportionally? Well, if she pays $3 for one soda, then she's going to pay $6 for 2 sodas, or she's going to pay $9 for 3 sodas. And every time that I set up this ratio and divide y by x, I'm going to get the same answer. 3 divided by 1 is 3. 6 divided by 2 is 3. 9 divided by 3 is 3. Therefore, the answer to this question is yes. And this work proves that it is, so please write it down. This is the number of sodas. This is the cost, number of sodas. Cost, number of sodas. Cost, number of sodas. 3 sodas is 9, 2 sodas is 6, and so on. The second question says she also spends $10 to get into the game, and if X represents the sodas purchased and Y represents the total cost of the game and the sodas, are they proportionally related? Well, if she buys 1 soda, I'll do that down here and I'll draw a line, and actually I'll erase that so there's more room. Okay, if she buys 1 soda, then she's going to pay $10 to get into the game, plus $3, which is 13 total. If she buys 2 sodas, then she's going to pay $6 for the sodas, plus $10 to get into the game, which makes 16. So that'd be 16 over 2. Now let's see what happens when we do y divided by x. 13 divided by 1 is 13. And 16 divided by 2 is 8. Therefore, this is not a proportional relationship anymore because I don't have a constant of proportionality anymore. I'm getting a different answer every single time that I do the y divided by the x. So the answer is no. Done.